Today is one of those days that I am sorry that I'm not here with you because I get to teach you this word, asymptotes. It's one of my favorite words, asymptotes. This is an actual word. I did not just make up this math word, okay? Now, there's some rules about the words asymptotes, okay? Number one, we don't need to unnecessarily stress the first syllable of this word. Don't do it. Number two, we're not going to abbreviate this word. Because even if we did, it would be ASY and not what you want it to be. Okay? Third rule, and most important, we don't need to walk down the hallway telling each other we're going to kick each other in the asymptote. Because I can promise you what will happen. You will get sent to the office. And the principal will say to you, "Why were you using such bad language in the hallway?" And you will say, "It wasn't bad language. Mrs. Kingston taught us this word, and I will get called to the office." I don't want to get called in the office. So you need to know what it means. Okay? Let's see. Are you going to be okay? All right. So this is what I need you to know about an asymptote. Let's fill in this table right here, and especially even this table right here, so that we can get to where we need to be for this definition. Okay? Any ideas? Where should we start? You have your calculators, right? Yes? Maybe? So if we put this function into our calculator, be real careful when you put this in, okay? Let's see if mine will be nice. Of course, mine's not being nice because I'm trying to show you. See, it has to load everything. Let me zoom in just a second. I'll zoom back out so you can see the worksheet in just a second, okay? Is yours on? Let me see yours real fast. Thank you. That's okay. Look how she put the equation in. She was very clear to put the equation in almost exactly like it is written on the page, right? Now, she probably didn't put in 2 times x. The calculator probably did that as well. But remember, you can get a fraction by pressing Control Divide. You can't see that. Control Divide. See that little fraction button right up there? Control Divide gives you a fraction, and you can literally enter the top and then enter the bottom. Okay? Just be real careful about that, because if you're not everything will be in the denominator like it needs to be, and then you just get wrong answers. Okay? So when we look at the table, after we look at the graph for a moment, we look at the table. What do we get at 1? When x is 1, what's y? So like 0.666 something. Now we know that that's 2/3, right? So I'm going to go ahead and put 2/3. Okay? What is y when x is 2? -2. What is y when x is 3? -6. 4? What's it say? What's it say on your table? Undefined. I think it's what it says is UND. Or does it actually say the word undefined? Undeaf. Undeaf. Okay? Oh, let me zoom out. What about 5? 10? 6? 6 and 7 is 4. So 4 and 2/3, right? Okay? So you can zoom in a little bit further on your table by changing how you count on your table. Okay? I'm going to fill this in for you. I'm just not sure if I have time to show you how to change how you count on your table. Some of you already know, and that's great, but we can go back over this on Monday when I get back. Okay? When x is 3.5, it is -14. When x is 3.9, it's -38. When x is 3.8, now 3.9, y is -78. When x is 4.1, I get 82, and then 42, and then 18. So what's happening is I get closer and closer to 4 this way. It's getting what? Smaller and smaller, isn't it? Okay? What's happening when I'm coming this way? It's getting bigger and bigger, right? So what actually happens at 4? It doesn't ever touch 4. Nothing can live at 4. Look at the equation and make sure you understand why. What happens if I put in 4 for x right there? 4 minus 4 is 0. Who is allowed to divide by 0? Only person I know is Chuck Norris, and he's not in this class. Okay? So, we cannot have anything living at 4. That is where an asymptote is. Okay? So when we look at the graph, there's nothing right there. There's a curve this way, and there's a curve this way, but there's nothing at 4. And no matter how far down I scroll, this graph will get closer and closer to this line, but will never touch it and never cross it. Okay? Now, generally for an asymptote, we say it can't cross. There are some situations where graphs can cross an asymptote, but we're not even going to go there right now. Okay? I'm not going to say it never crosses, because that's just not true. Okay? But for vertical asymptotes, we're going to say it's a line that the graph approaches but never touches. Nothing can be there. So when I got called into the principal's office, he was like, "Why are you teaching these students these words?" And I was feeling very ornery at that point. And he's like, "Tell me what an asymptote is." I was like, "It's nothing." Which didn't make him very happy. But I was also not very happy because I was getting called into the principal's office, because my students were using their words incorrectly. So, because it's really nothing, right? Asymptote, nothing can exist there. It's nothing. Stuff can get closer and closer on each side of it, but nothing can live at 4. Okay? So what happens when you plug a 4 into it? We already talked about that. Okay? What kind of asymptote is this? It's a vertical asymptote. You could tell that because that's what the worksheet is called. Okay? vertical. Also because if I tell you the equation is x equals 4, you know that's crossing the x-axis at 4, which makes a vertical line. Fair enough? Okay, so here's the deal. Y equals x minus 4 over x minus 2. Okay? When we look at our table, y is 2, undef, 0, and 0.5. Where is my vertical asymptote? Okay, so I was hoping you'd say that because we have to have a conversation. I said, where's the vertical asymptote? And you said, at 2. Is 2 the equation of a line? No, it's not, right? So for vertical asymptote, you can't just put 2. You have to tell me where it is. We know it's crossing at 2. It's crossing the x-axis at 2. It's a line. We have to write it as the equation of a line. Does that make sense? Okay? So very quickly, you're all going to put, let's see, you guys put this one in, 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 you guys put this one in. Fill in your table, and in just a moment we will share tables, we'll share values, but go ahead and put these values, those of you I assigned, go ahead and put these values into your calculator. For those of you who are not in the classroom with me right this second, if you're listening to this on Friday, please go ahead and choose one of these and put the values in so you have a completed table by the time I share the rest of the information. All right, so those of you who did number 2, can you tell me what your table is, please? Negative 2.5, negative 6, undefined, and 8. Okay, so people who did number 2, where is your vertical asymptote? Very good. X equals 6. Okay? Those of you who did number 3, what is your table inputs? Or, excuse me, outputs? Undefined. Okay. 0. Okay. 0.5. 0.66. Where's your vertical asymptote? X equals -3. Good. Number 4, -0.25. All right. -1. All right. Undefined. All right. 2. Okay, where is your vertical asymptote? X equals 6. Okay. People who did number 5, what is wrong? What is your outputs? -5. Undefined. 6. 3.25. Okay. Where is your vertical asymptote? X equals -1.5. Okay. What about people on number 6? Undefined. -1. 0.5 and 1. Where is your vertical asymptote? X equals -4. Last one. Wait, what do you mean something's wrong? Okay, well tell me what you got. Undefined. -0.25. 2 times. Okay. 0.416. Okay. Sorry, that's not very clear. 0.416 is what it's supposed to be. Where is your vertical asymptote or asymptotes? Wait, we can have more than one? What? Yeah. Are these asymptotes related to the numerator or the denominator or neither? How? It's the bottom. Whoops, that's an O. It's the denominator of the fraction that's not allowed to be 0, right? So to find the asymptote, you pretend it's 0. You make it equal 0. If I make this equal 0, 2x minus 12 equals 0. Add 12 to both sides, divide both sides by 2. Guess what I get? X equals 6. Boom. Okay, so why does this one have 2? I could do 2 things, right? I could add 4 to both sides and take the square root of 4. What is the square root of 4? Plus or minus 2. Or I could factor it and get x plus 2x minus 2. And when I set each one of those equal to 0, guess what I get? Positive 2, negative 2. Okay? So how can the asymptotes be determined using this part of the expression? Set them equal to 0. Good. Okay? So that's vertical asymptotes. There are some problems on the back. I don't know if you noticed there was a back. There's some problems on the back. Okay? Go through just looking at the table and decide where the vertical asymptotes are. Oh my gosh, then it asks for the domain. Your genius is at domain now. If you know where the vertical asymptote is, you know where the domain is not, don't you? So if you know there's a vertical asymptote at where? X equals -2, where's the domain? Not -2. X is not equal to -2. Okay? So that should hopefully give you an idea for the rest of these. Here are 5 more problems. There is an example just to make sure. Here's 5 more problems for you to do. Okay? If we have vertical asymptotes, what else do we have? Horizontal asymptotes. Okay, so let's look at this worksheet. Okay, so far in basketball season, during games, Charlie has shot 30 free throws. Unfortunately, she's made only 13 of them. So she's probably been running a lot, hasn't she? Okay, all right. Like just laps or like, what are they called? Touches? Okay, sounds good. All right. So up to this point, what is her stat for percent of free throws made? What's her stat for percent of free throws made? Well, she made 13 out of 30, which equals what? 0.433 repeating, which makes her percentage what? 43.3%. That's really not great, is it? No. I mean, does she even stay on the team? Maybe. Maybe. Maybe she's really super good in defense. I don't know. Okay. Maybe she's a good free throw or three-pointer shots. Yeah, I didn't mean the free throw. You know what I'm saying. After such a poor start, Charlie gets some advice from the coaches and practices daily. If she does not miss another shot, another free throw for the remainder of the basketball season, how many consecutive free throws will she need to make before her percentage reaches 80%, or 90%, or 100%? So first of all, let's go through this worksheet right here, okay? Right now, she's at 33/30. Her decimal is, we figured that already, 0.433, which makes her percent 43.3%, correct? So the decimal, what if she made one free throw? The next time she got up to free throw, she made it. I almost said bat, but I know that's a wrong sport. Bad. Okay? So that means she's 14 out of 31, right? What she made over how many she's attempted. Okay? Which makes her percentage what, or her decimal what? 0.451, which makes her percent what? 45.1%. What about if she makes 2, the next one? 15 out of 32, which gives her 0.469, good, which makes her percent 46.9%. Okay? What about 3? 16 out of 33, which makes her decimal 0.485, and her percent? Good. What if she made 4? 17 out of 34. Her decimal is, exactly 0.5, which makes her percent exactly 50%. Okay? What if she makes 5? 18 out of 35, except I wrote 4, but I meant 5. 0.514, which makes her percent, good, 51.4%. What if it jumps to 10 then? Yes, 23 out of 40, right? So it's 10 from the beginning, right? So 10 here and 10 here, which is 23 out of 40. What's her decimal then? How are we getting her decimal? Just by the way, because some of you were sitting there not doing anything. 23 divided by 40, right? That's literally what we're putting in the calculator, okay? So 0.575, perfect, 57.5%. What about if we jump to 20? Add 10 more to here, right? So 33 out of 50, or we're adding 20 to the beginning, remember? What is that decimal? 0.66 exactly, or is it repeating? Okay, so that gives us 60, oh, okay, that's fine. 66%, because it was exact. What about 50? Add 30 from here, or 50 from the beginning. 63 out of 80. Yeah, she either got tired of running or actually listened to her coaches, right? Okay, which is always a good plan. Okay, so 0.788, which makes her percent 78.8%. 100 in a row. 113 over 130, which makes her decimal 0.869, and her percent 86.9%. Okay? What about if X, we don't know? Where did these numbers all come from? Remember I said we could be adding stuff from the previous one or back from the beginning, right? 13 plus X over 30 over X. Very good. Okay? Very good. So what equation would relate these two quantities? To get the percent. That's what we're trying to find is the percent, right? So we did this to get the decimal. How'd we get the percent? Yeah, so we say 100 times 13 plus x over 30 plus x. And when you graph it, guess what it looks like? How about if I just show you? Is that all right? Like that. And right here, what's happening at 100? After how many consecutive free throws will her percentage reach 80%? How would we figure that out? That would be our y value, right? So we divide both sides by 100 and then cross multiply. Okay? So we would find that that is 55. Or we could even just look at our table, because that's what you guys did, right? You looked at your table to see where does it get to 80. And that's at 55 free throws. Okay? When will her percent reach 90? You have to do quite a bit more scrolling for that one, don't you? Okay, let's say 140, because that's the right answer. Okay, 140 free throws. When will it reach 100%? Never. Never, ever? Once you miss, you can never have 100% anymore, can you? Now, if you want to get really technical on these calculators, as amazing as they are, they're still calculators. They're still not something that can imagine like infinity or something like we can. So at a certain point, there's not enough spaces, there's not enough place values at the end, and it rounds it, and you get to 100. Just so you know. That's not a challenge for you to go find it. I'm just saying it does happen. Okay? Often, when using rational functions, wait, what is a rational function? Because I'm just telling you right now, this is a rational function. What makes it a rational function? Doesn't it make a ratio? That's a rational function. When you plug in larger and larger numbers for x, the answers for y keep getting closer and closer to a certain value. This value is called a limit. Guys, that is calculus. When you're in calculus, you find limits. You deal with limits. You work with limits. You understand what a limit means now, you're going to have a much easier time in pre-cal and calculus. Okay? A limit has to do with an asymptote. It's getting closer and closer and closer. Can we say at some point, okay, it's going to be about 100? Can we say that? That's a limit. Is it ever going to get to 100? You know that by saying it's going to get to about 100. But you don't have to say, well, it'll never get there because we already missed one, blah, 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 blah. You don't have to say that, right? You just know that inherently, okay? That's a limit. In the basketball problem, what's the limit on her percentage? It's 100%, right? She's not going to get there, but she's going to get close, okay? Graphically, this makes an asymptote. What kind? Yeah, because guess where it is? Right there, right? It's a horizontal asymptote. No. Okay? So, here's some problems right here. Here's some problems right here. I want you to carefully, again, we talked about putting rational functions in your calculator. Make sure you have something on top and something on bottom, not just a bunch of parentheses. Okay? Put these in your calculator. Find the horizontal asymptotes. Here's the difference, okay? When you put this one into your calculator, anybody put it in their calculator yet? Y equals, or f of 1, I guess in our case will be x minus 4 over x minus 2. Well, it counts weird, doesn't it? So you're going to have to change your scale on how you count. Hopefully you all know how to do that. If not, no? Do we not know? Let me see your calculator real quick, please. It's okay. I'm going to turn this off. Is that okay? Okay. Where are you, cursor? There you are. So I'm just turning off the graphs that I don't want to delete stuff out of his calculator right here. So I'm just going over to this place and clicking so that that check, oh, you can't even see that. I'm going over to this place right here, that box, and clicking so that the check is no longer there. So all that I can see is that rational function that I asked for. Okay? So when I go look at the table, let's see, menu, let's look at the table 7. you can either have a split screen table or remove the table. We want a split screen table, but we also know that Control T pulls up a table for us. If you don't remember that, remember now. Okay, f of 3 is where we have ours, but I don't want it to count by 1, 2, 3, 4. It's going to take me forever to scroll there, right? Menu, Table, Edit Table Settings. On Edit Table Settings, we want to start at 1,000, right? Table Step, how do I want it to count? By thousands. See how it goes now? 1,000, 2,000, 3,000, 4,000. That's what I need for my table, isn't it? Okay. So 1,000, not F3 because of where I had to borrow his calculator. Go away. Not you. Not the people, the numbers. Okay. So this is, was it F3? Oh, it's not the right one? Okay, sorry. Let me go find it. Escape, escape. Control T. So it's x minus 4. Let's see. X minus 4 over x minus 2. Now that should be right, right? Control T. So now when I go over here, oh, now it changed my table settings back. So I have to go back and change my table settings again. Okay? You guys can do that when you have a chance. Go ahead and answer it. This is 0.998. This is 0.999. This is 0.9993. This is 0.9995. Where's it going? What is this number getting closer and closer to? 1. Okay? Y equals 1. Fill in your table, figuring out where it's getting closer and closer to. Understanding that some of these are not getting closer to anything, so it's very possible for you to have no horizontal asymptote. Okay? The last worksheet that you have says first look at the. When you're trying to find horizontal asymptotes, first you need to look at the degree. Okay? Well, look at the exponents, I guess. Okay? Find the greatest exponent used in the numerator and the greatest exponent in the denominator. In each, the greatest exponent is called, I just spoiled it for you already. Do you remember what it's called? The degree. Okay? Once you find the degree, go ahead. Once you find the degree, you have to compare them. The degree of the numerator is greater. If you decide the degree of the numerator is greater, then the function has no limit, which means it has no horizontal asymptote. Okay? If it has no limit, it has no horizontal asymptote, and you just write no horizontal asymptote. Okay? If you look at the degrees and decide that the numerator and the denominator are the same, if the numerator and the denominator are the same, then you have to look at the leading coefficient. Now remember what a coefficient is. Coefficient is the number in front of the variable. So if we were looking at a problem from this page, we'd be looking, let's see, the degrees are the same here, right? So this is a coefficient, a leading coefficient, and this is a leading coefficient. So in this case, I would have 5 and negative 3. We would just divide them. Y equals 5 over negative 3. And that would be where our horizontal asymptote is. Okay? Then if you look and decide the degree of the denominator is greater. So in the denominator, if the degree of the denominator is greater than the degree of the numerator, then the function has a limit of 0, which means its graph has a horizontal asymptote at 0. So y equals 0. And you guys remember that that's the x-axis. Okay? So, for example, here's a function, a sample function, finding the degree of the numerator. What is the highest exponent in the numerator? Well, that's 2. Look at the denominator. What is the degree? What's the highest exponent in the denominator? Well, that is also a 2. So when you compare them, you find out that they are the same. When they are the same, you look at the leading coefficients. So the leading coefficient is 3, and the leading coefficient of the denominator is 5. So that means your horizontal asymptote is at y equals 3 over 5. That's the horizontal asymptote. That's the limit. Okay? Look at problem number 2, example number 2. What is the degree of the numerator? What is the highest exponent in the numerator? Well, it is 2. What is the degree of the denominator? What's the highest exponent in the denominator? Well, that's a 1. There's not 1 there, so you know it's an understood 1. Remember that? Compare them. Which one, are they the same? Which one's greater? Well, 2 is greater than 1, as far as I know. So we're going to say the degree of the numerator is greater. So the numerator is greater. If the degree of the numerator is greater, where is our horizontal asymptote? Numerator is greater, same, denominator. Okay, so numerator is greater. If the degree of the numerator is greater, the function has no limit and no horizontal asymptote. Here's the deal, though. We cannot leave it blank. If we leave it blank, what do we think? We think that we didn't do it. So we write no horizontal asymptote. Okay? I'm going to leave the last two for you to do. So keep in mind that on our vertical asymptotes page, we talked about both vertical and horizontal today. Our vertical asymptotes are going to be x equals something because it is vertical, so it is crossing the x-axis. Okay? And you had these 5 problems to do at the bottom and these 3 problems to do here at the top. All right? On our horizontal asymptotes page, we know our horizontal asymptotes are going to look like y equals something because they're going this way. Horizontally, they're crossing the y-axis somewhere. You have these 7 problems and this question to answer at the bottom. Okay? And on this last page, the Finding Horizontal Asymptotes page, you have number 3 and number 4 to complete. Okay? Are there any questions? Have a great day.